I think a lot of us got A, B, and C pretty comfortably. Right, so write an equation to be used to calculate Jade's score. I saw everyone at least end up doing 20 times, trying to think of what variable I want to use here. W is equal to 100, okay? Now, two things I want to point out. I'm always, especially anytime there's a context, going to be very intentional about the variable I used. The reason why I didn't use Q is because I know later I'm going to want to use Q for the number of questions she got right. So what do you think I mean by W? The worth of each question, or maybe a V for value of each question. And here's something I would recommend. I would define your variable every time. Now, this is something I noticed recently while actually looking at a couple of yours. Do y'all know what punctuation symbol you can use to indicate that you're about to do a definition?
Semicolon.
Close.
A colon.
A colon. Most people know that a colon, which I just realized is 6th grade, I don't need this. Most people know that a colon introduced a list at the end of a sentence, right? We've heard that somewhere. But did you know that's not actually what the sole purpose of a colon is? A colon can introduce a list at the end of a sentence. It can introduce a single word at the end of a sentence. It can introduce an entire independent clause at the end of a sentence. And the reason why is whatever comes after a colon simply clarifies, defines, or explains what happened before the colon. For example, I went to Publix to get some cake ingredients. Right now, do you have any clue what those cake ingredients are?
No. Eggs.
Okay, so if I were to say I went to the Publix to get some cake ingredients, I could then put a colon and then say eggs, milk, flour, because I am now clarifying or defining what ingredients I went to get. The same thing is true if you were to use a colon to separate two independent clauses. When I first started doing ACT prep, a really common one I would talk about to illustrate the difference between a semicolon and a colon is, I went to the park yesterday, Sally was there. If I just put a semicolon between those two things, it can separate two independent clauses. And it's just saying, hey, these two things happened. But if I put a colon between them, it completely changes the tone of that sentence. I went to the park today, colon, Sally was there. Because Sally was there. Why did I go to the park? Because I knew Sally was going to be there, right? So what comes after that colon clarifies, defines, or explains what happened before it. So what I could do here is W colon worth of each question. I am defining what the colon, or what the W is. Alright, so all that to say, a colon, what comes after it, clarifies, defines, or explains what came before it. That's why if you ever look in a dictionary, a lot of times there's a colon after the word, but before the definition. What comes after the colon clarifies, defines, or explains what came before it.
Or on a digital clock.
Or on a digital clock. I don't think it's the same case there. I don't know what the purpose of that is. What do you mean?
Hour and minutes has separated.
It does separate them, but is what's, are you clarifying, defining, or explaining what came before it? And I don't know that you are. But okay, so notice the worth of each question is 5 points. And so that's why later we did 5Q is equal to 70. No, at least a C minus, so greater than or equal to 70. Notice now Q is questions correct. Alright, we go with just how that structure of how we can define our variables and how we work all that out. Okay. So D, suppose she got a score of 60% and then was allowed to retake the test. On the retake, she got all the questions right that she got right the first time, and also got half the questions right that she got wrong the first time. So, Braden, start us off there. What did you do at this point?
I figured out how many questions she had to get right for her to get a 60, so I did 5Q equals 60.
Okay. If we want to know, if we know she got a 60%, that's where we need to start. Yeah, 5Q is equal to 60. And so Q came out to be 12 questions. Start at the beginning. There's important information there. Right? And so on the retake, she got all the questions right that she got the first time, 12. And also got half of the questions right that she got wrong the first time. So, McKay, how many did she get wrong the first time, and how many more did she get correct this time? She got 12 questions correct originally. How many did she miss?
4.
She only missed 4. How many questions were on the test?
20.
So she got 12 right, so she got 8 wrong.
Yeah.
Okay, that's what I was trying to establish, right? So she got 12 questions correct, so she missed 8.
I did have 8.
That's what I was wondering if you went ahead and did that. So how many more did she get right?
4 more.
Alright, so 16 correct on retake. So Braden, are we done at that point?
Got about an 8.
No, you have to find the percentage.
You need to find the percentage again, right? So 16 questions right times the worth of each question is 80%.
I knew that.
Did y'all know that you made this way harder than it had to be though?
Nope.
So this is totally valid. It's a great way to approach it. However, if she was at a 60%, and then 100% is all the way over here, but she got half of the questions right that she got wrong last time, what is she making? Right down the middle, 80%. I didn't have to find out how many she got right or wrong. Splitting the difference between 60 and 100. Any questions about that? Does that make sense? Okay. I bring that up because of what we're looking at today. I've already passed it out to you. 2.1, think about it, group work, and hopefully we'll get to the wrap up today. A lot of times we are very used to just algebraically solving an equation or setting up an equation almost to a fault where we actually lose the meaning of some of those equations. So, this is the 2.1 side. There's a second side that we'll look at hopefully tomorrow. But 2.1, I can examine a cluster of equations and predict the solution. Sometimes no solution or infinitely many solutions. By the way, let's recap and remind ourselves, because we talked about this with inequalities yesterday. When is there no solution? We've only talked about it with inequalities, but in general, what does it mean that there's no solution?
Nothing will make the equation true.
Okay, so with the inequalities, there's nothing that will make the inequality true, or nothing will make the equation true, right? So if it's infinitely many solutions, well, for inequalities, it was almost always infinitely many, but when the solutions are negative infinity to infinity, what does that mean? Anything will make the equation true, right? And so what we're going to do is we're going to examine clusters of equations, and notice it says predict. It doesn't say solve right away. We want to start to get comfortable enough to where we just kind of look at things and can recognize some patterns and structures there. Then we're going to use algebraic manipulation, use your inverses, use your properties of equality, and your identities to check those predictions about the solutions to an equation. Does that make sense? Okay? So I want to do just the first set. I want you to do just the first set on your own, or with your small group, and then we'll come back and talk about it pretty soon. If you get done with number 1 quickly, go ahead and move on to number 2. But I do want I want us to discuss before we get too far ahead. So go ahead and start talking with your small group about number 1. Again, look at the equation, make a prediction of what you think the solution will be, which may be that there are no solutions or that there are infinitely many solutions, and then check yourself algebraically. But make that prediction first. Make sense? Look at the pattern of the equation, think through those ideas, talk it out with each other.